Alright, so next we're going to look at RRAM, or right endpoint RAM, and again we're still going to use the function f of x equals x squared over the interval from 0 to 2. So again, here's my function, f of x equals x squared. I've sketched it over the interval from 0 to 2. I've broken up the interval from 0 to 2 into 4 subintervals of equal length. But now I'm going to use the right endpoint of each subinterval to determine the height of my rectangle. And it's going to look something like this. There's the first rectangle determined at 1/2. The next one would be determined at 1. The next one at 3/2. And then the next one, the final one, at 2. So you can see on this one, the estimate is going to be a little bit over what I want. It's going to be a little bit of an overestimate. Alright, so using the right endpoint, you can see that this would be the first subinterval here, 1/2 times f at 1/2. This would be the second one, and so on. Alright, so we're using the right endpoint of each interval to determine the height of the rectangles. Alright, so working that out, we're going to get, alright, so working this out, I end up with 15/4. Alright, so the third and final way of approximating under a curve is using MRAM, or midpoint RAM. So again, here's my graph of y equals x squared, and I'm going to break up again into 4 subintervals of equal length. But now, even though the width of each one is still going to be 1/2, I'm going to use the midpoint of each subinterval to determine the height. So the midpoint of 0 to 1/2 would be 1/4, and I'm going to use that to determine the height of my rectangle. So the midpoint of 1/2 and 1 would be 3/4, so I'm going to use that value to determine the height of my rectangle. Here it's 5/4, so I'm going to use that value to determine the height of my rectangle. And the final one's going to be 7/4, and I'm going to use that value to determine the height of my rectangle. So you can see in this particular case, this gives us a pretty close approximation actually, because everywhere where I'm going above the curve, I've got a little bit sort of underneath it that sort of balances it out. Okay, so when finding the middle endpoint RAM then, the width of each one of my rectangles is still 1/2, but now I am multiplying it by the function evaluated at 1/4, again because 1/4 is in the middle of 0 to 1/2, and then I continue to proceed in that fashion. Alright, so proceeding in the same way, here is the full expression for MRAM, my approximation. So now I've just got to plug in all of my values into the function and just work this out. Alright, so finishing this off, plugging everything in and evaluating, we get that MRAM is 21/8.